Hi, this is Synthchaser from synthchaser.com, and today I'm going to be restoring this beautiful Whiteface ARP Odyssey Mark I. It's a model 2800 original ARP Odyssey, and the problem with this is we turn it on and nothing happens. The little power light illuminated rocker switch doesn't even light up. If I have my amp turned up high enough, I can hear a little thump when I turned it on. But that's it. There's not even lights on and nobody home. There's just nothing. So what we're going to do is we're going to do a comprehensive restoration of this ARP Odyssey. If you've seen my other videos, I take kind of a methodical approach to repairing and restoring a synthesizer. We'll take it apart. We'll inspect all the boards, we'll recap it entirely, so we're going to change all the polarized capacitors, not just on the power supply. For the ARP Odyssey, I change all the IC chips, the op amps and the CMOS chips that are in here. We're going to also replace the sliders. A couple of them here are broken. They move fairly smoothly, but no doubt they're dirty from being 45 years old. So we're also going to fix up the key bed. You can hear it's kind of clacking sounding, so we're going to put new bushings on and we're going to clean the bus bars. So to get this style of ARP Odyssey open, we're going to remove some screws. There should be 3 screws here. There's one missing, but here, here, and here on each side. And then there's a bunch of screws on the bottom here, and we'll just take those out, and then we'll be able to lift the panel with the circuit boards inside and the key bed attached just out of this little U-shaped plastic shell that it sits in. So now that I've taken all those screws out, I can lift this up and out. In this case, I'll just tilt it back and we'll have a peek under the hood. And what we've got up here is a 3-bus keyboard. So you see there's 3 bus bars on the keyboard assembly. There's 3 circuit boards. This one on the left is board A, this one is board B, this one is board C. There's an interconnect and the power supply, and that's all there is to it. And right off the bat I can see that the interconnect board is not seated properly. So it's not even plugged into board A there. So that's a pretty good reason why things aren't working. Just for fun, let's plug it in and see if the keyboard now works. So let's turn it on now. This is why we have to change the sliders even if they feel smooth. But yeah, basically I mean, it's making some sound now, but it's definitely not working. So we're still going to go through our plan of methodically recapping, changing the chips, and then once changing the sliders, addressing the key bed, and then when we're done, we'll test it out, and if there's anything that's not working, we'll troubleshoot it and fix it and get this thing working 100%. So I'm going to take this out and set the shell aside, and we'll get the boards out of the keyboard. So this here is board A. This basically gets your keyboard control voltage from the keyboard. So the keyboard plugs in on the back side of this. And on the 3-bus model, there's an extra wire here for a separate trigger signal that's sent from the key bed to this board. So this board generates your keyboard control voltage for your first and second voices, because it's a duophonic synthesizer, your gate and trigger. And then it has your transpose switch and transpose circuitry, pitch bend, potentiometer, or if it's a model with the PPC pads installed, that would be on this board. And then there's also the noise generator circuit is on this board. This is board B. Board B has the LFO and it has your 2 oscillators. And you can see one oscillator is here, the other oscillator is here. Here's the thermally coupled transistor for the exponential converter next to the Tempco there. Again, sliders are super dirty. Good thing we don't have to take these all apart. We're just going to be putting in a kit of replacement sliders, because that would be a real chore to take these apart. Also on this board is the ring modulator, and it's an exclusive OR ring modulator. It performs an exclusive OR on the square waveforms from oscillator 1 and oscillator 2. It's not a true multiplying ring modulator. This is board C. Board C has the filter, voltage controlled filter module, and different Odysseys use different filter modules. This one is an early one, so it uses the earliest filter module for the Odyssey there, the 4023. Some Mark II Odysseys use a 4035 filter, which is a ripoff of the Moog ladder filter. And then most later ARP Odysseys, Mark II, Mark III, use the 4075 filter, which is found in the Omni, Quadra, and pretty much all the Pro DGX and all late model ARP synthesizers. Besides the VCF, there's also a high pass filter on this board, the VCA, voltage controlled amplifier, and then the envelope generators. There's two envelope generators. There's an attack release envelope generator and an ADSR attack decay sustain release envelope generator on this board. Last but not least, here's the power supply. It's not a huge power supply, but it's more than adequate for the Odyssey. You don't need to go spend $200 to put a Power 1 linear supply in. This is perfectly adequate. But what I do notice, and I'll shine a light here, you can see that these filter capacitors, this one here is kind of cracked, but this one seems to have vented out a little bit. So I'm interested to measure its actual capacitance and ESR once we get this out. What I'm going to do now is I'm going to remove all the polarized capacitors, so these electrolytic capacitors, and then all these little tantalum capacitors that are sprinkled throughout the keyboard. They're red, but because this is so dirty, some of them look more like brown or black. I'm going to take out all the IC chips, the voltage regulator here, and all the CMOS and op-amp IC chips. I'm going to take those out because we're going to be replacing those. And then I'm going to take out all the sliders. So all 34 of these sliders are going to come out, and we're going to be left with some pretty bare looking boards. And I'm not going to show you the time-lapse cheesy music desoldering montage this time. I'll just show you after I get it done. As for the power supply capacitors, so this electrolytic capacitor with the crack, I'll show you. It has just a little bit of cracking on this this rubber end piece, and we'll measure the ESR of that. I measured the capacitance of both of these, and they're actually okay. So the ESR for this one is 0.014 ohms, and anything under, for this value of capacitor, anything under 0.15 is fine. So that's still within spec, even though it's old and looks ugly. This one here, where it, some of the stuff actually came out through the rubber there, we'll measure the ESR of that one. The capacitance on this one again tested okay. The ESR here is 0.340 ohms, so it's well over the maximum of what it should be. So this capacitor has actually failed. So good thing we're doing this. Here are the boards after we've taken all the stuff off. So all the sliders are gone, the polarized capacitors, including that bad electrolytic one, the temperature compensating resistors, the Tempcos are there, and then the op-amp and CMOS chips, and the voltage regulator is off. But as you can see, these boards are totally filthy. So we're actually going to give them a bath before we do any work on them. So I've given board B and board C a nice bath in the sink with all the openings for the sliders. They were really, really dirty. So now they're much cleaner. Board A over here, I didn't give a bath, but there was only one slider on that board, so it wasn't so bad. But now at least I can get in to see the traces, and when I solder everything back in, it will actually stick. So while I'm here soldering the power supply capacitors on, I noticed something on this board, and we'll see if you can notice it before I tell you. And it is this. This trace here and its corresponding other side here have burned, and the trace got destroyed. And what this is let's see, on this side it's the green earth wire from the power cord. Apparently it was at a different potential than ground of the power supply at some point in this instrument's history, and these traces here vaporized. So for the safety of the equipment and anyone who uses it, we're going to be reconnecting both of those traces. So now that I've installed the capacitor and IC kit here and replaced the Tempcos, I'm going to install the Synthchaser slider kit. So I got 34 brand new sliders. They're drop-in replacements. They're just like the originals. Same value, same taper, and they just drop in to where the old ones were. And it's a whole heck of a lot easier than disassembling and cleaning the old sliders. Yeah, you really have to take the old ones apart and clean them. You can't just spray them with contact cleaner because you're just going to be moving the junk around inside. And I think I've showed in previous videos details on breaking the sliders down and why that's necessary to get them clean. But with 34 of them on the Odyssey, that's just too much work, and it's just way more cost effective to buy this this slider kit on synthchaser.com. So I'm going to put that in, and then we'll reconnect the boards and test everything out. One more thing I'm going to do while I have the sliders off. I've washed the boards, but I'm also going to clean all the switches here just to make sure that they are all good. I installed all of the brand new sliders and they're looking great. Before we reconnect everything and test it on the bench, we're going to do a little cleanup on the key bed. We're going to test the power supply out of circuit from the rest of the keyboard. I put a replacement power switch here on board C since the little lamp that shows that the power was on wasn't working. And I've plugged the power supply in, and with the power supply disconnected from the rest of the synthesizer, I'm going to test it out now. I just want to make sure that everything is okay on the power supply before I connect it to the rest of the circuit boards. So we'll turn the power on, and the way that we can test the power supply is with the multimeter. Take one of the 3-pin connectors, and we'll put our black lead here on the black wire, and the red lead on the red wire. And now we're testing the 15-volt supply, which is 14.95 volts, and we'll just do a little calibration now. Obviously we'll need to do this again once we connect it to the load of the keyboard, but just kind of trying to get it roughly dialed in now. We'll adjust this trimmer here on the right. This trimmer is for the plus 15 volt rail. Now what we'll do is we'll move the red lead over to the purple wire, and this will test the negative 15 volt rail, which is right now sitting at negative 15.01 volts. So the trimmer for the negative 15 rail is right here, and we can just gently adjust it and get it at minus 15 volts on the nose. Again, this has no load connected, so I'd expect the voltages to drop once it's connected to the rest of the keyboard, so it will need calibration again. We're just making sure that this is working okay before we connect it to our circuits. This is the early ARP Odyssey 3-bus keybed. Most ARP Odysseys had two bus bars, so these little gold-plated bars that run from left to right are what are called the bus bars. One of them is fed some current, and there's a resistor chain here, and that is what determines the keyboard control voltage. So one bus bar is for keyboard control voltage, and then another bus bar is for gate. So when a key is pressed, that bus bar detects it. The early ARP Odysseys, like this one, used 3 bus bars. The third bus bar being fed through these little capacitors here, little RC network, which generates a little spike or trigger when you press a key on the key bed. Later ARP Odysseys used circuitry to detect a change in the voltage of the bus bar and generated a trigger signal that way. The key actuation method is a little different. Later Odysseys use a little wire that makes contact with the 2 bus bars. This one uses springs. So, and when you press a key down, it's pulling these springs over on top of the bus bar, and that's what makes contact. So what we're going to do is we're going to clean up the bus bars here to make sure that when the spring touches it, it's going to make good electrical contact, and we're going to change the key bushings. For reference, here's the later style key bed. You can see that there's a key contact wires, and when you press the key, it's going to simultaneously, or close to simultaneously, hit both of these bus bars. So it's a little different mechanism on the earlier one that I have, that I'm working on now. On this style key bed, this is what it looks like once you get the keys off. You see a little white plastic lever there that is kind of like a fulcrum that pushes the springs against the bus bar. But one thing to be mindful of is there's little plastic caps on top of there. They're lubricated with lots of goop, and they can often stick inside the key. So here you see it in there. You want to take that out before you wash the keys. These keys are totally gross. So I'm just going to wash them and dry them. And as you can see, the key bed is really gross with grime and dust and pet hair and all kinds of stuff. So we're gonna clean that out really well. I took all those little plastic caps off for each of the keys. I didn't want them to get lost when I cleaned the key bed. I cleaned them up, and look what came off of them. That is nasty, greasy, nasty, dirty stuff. So I don't know. Maybe I'm being anal for cleaning this up, but yeah, I just couldn't leave it like that. Another thing that I do is I inspect all the connectors as I work on the keyboard. And hopefully you can see, but the third pin from the left, you can see down into the housing, and you can see the contacts. And this third one from the left, the contact is kind of compressed, so it's not going to make good solid contact when I plug this in. So what I'm going to do is I'm going to take this out, and I'm either going to bend back that contact to restore the springiness to it, or if it's shot, I'm just going to replace it. I've cleaned each point where the springs contact the bus bar with this fiberglass scratch pen. Alternately, I could have pulled the bus bars out and replaced them, but they weren't in that bad of shape. I put new key bushings on after leveling the key bed. And I put those little plastic caps back on and put some fresh lubricant there so the keys move smoothly. So I've connected everything here on the bench outside the case. I have board A, board B, board C. On the back I have the interconnect board connecting these boards together. I have the power supply plugged into each board. I put a spare switch here so I could get it laid out all nice and flat on the bench. I'm connecting a spare jack just with some alligator clips. I've got the signal connected to board C, coming from board C, and I've grounded it here on the power supply. Normally that's grounded to the chassis. And I've plugged in the key bed, and there's the one connector for the 2 bus bars, and then there's that third connector which I just have connected to the bus bar with an alligator clip. And I dialed up a basic patch, and it works. So I need to go through everything and see if everything's working, and I need to get calibrated and in tune, but this Odyssey is back to life. So first problem became obvious pretty quickly. So this is oscillator 2, and this is oscillator 1. And there's nothing there. So we can take a look with the oscilloscope at the outputs from the oscillator here on board B. And oscillator 2 triangle or sawtooth wave comes out, sawtooth wave comes out on pin 11. So that's our oscillator 2 sawtooth. And then our oscillator 2 pulse wave comes out here on pin 9. And that looks okay. But if we take a look at the same for oscillator 1, the square wave is on pin 15, which is this one here. And we just saw it toggle there very briefly, but it's going very slowly. The sawtooth is on pin 10 here, and you can see it dropping very, very, very slowly. So there's a problem with oscillator 1 that we're going to need to fix. So starting at the IC chip here, I kind of started back here and I worked my way back to here, and I'll show you the difference between the input and output to oscillator 1's IC versus oscillator 2's IC. So pin 11 here on the working oscillator. This is the output to this first stage on the IC, and this is the output on the one that isn't working. See, it's moving very, very slowly. We can take a look at the input there, which is on pin 12, and here I've got a sawtooth wave that's between 7.2 volts and 12.8 volts. If I look at the input on the working oscillator, you can see here it's between 7.4 volts and 15.2 volts. So the oscillator 1 here, it may not be reaching a high enough voltage to correctly change the state of the gates on this chip. So we need to go a little further back in the circuit and look at why this input isn't reaching the full 15 volts of the supply. So I probed around a little bit and I found a suspect FET transistor here, and I pulled it out of circuit and I'm testing it in my transistor tester, and there's an open junction. See, it just shows as there's just a single diode between 2 and 3. It's not detecting it as a MOSFET. So this transistor is bad and needs to be replaced. So I grabbed a new old stock replacement, which fortunately I have a stockpile of, and you can see that this one tests correctly. It's an N-channel JFET. So we'll put this in and see if that brings our oscillator back to life, or if we still have other problems with it that we need to figure out. And sure enough, with that bad JFET changed out, now oscillator 1 is working. Here's oscillator 2. And now we can get them both together. So one problem down, and I'll continue going through the keyboard and checking everything out. So I've got it all tested and calibrated now, and as I was calibrating things, I found a bad trimmer here on board A. When I went to calibrate it, I found that the control voltage on the keyboard kind of was fluctuating, so it wasn't getting a steady control voltage when I hit a key. Because these trimmers, they're kind of unsealed, so stuff gets in them, or they get worn out, and when you go to adjust them, they get to be noisy. Just like you have a scratchy slider, you can have a scratchy trimmer pot too. So I replaced that one, and everything else calibrated just fine. I like the sound of this 4023 filter that's on the Mark I. It's a 2-pole filter as opposed to the 4-pole filter found in the later ones. But I think it sounds awesome. So one last thing I'm going to do before I put this back into its case is give the outside of the case, the panel here, a good cleaning. You can see stuff kind of got under the knob, and it's just a little bit dirty. So I'm going to clean it up so it looks as good on the outside as it'll sound. So this is a very old, early ARP Odyssey, and there's a lot of modifications you can do to these, like adding CV inputs and outputs on the back. You can put LED sliders, LFO free run switches, and the like. But because this is an original 2800, I wanted to keep it as true to its original as possible. I mean, I changed the sliders with new sliders, but with the slider caps back on, they're going to look exactly like the old ones. There is one modification that I am going to do, and it's about this. So the high-level output of the ARP Odyssey is an RCA jack, and the low level is the 1/4-inch phone jack. And nobody uses RCA jacks, but everyone uses the phone jack. So what I'm going to do in as least an invasive way as possible is I'm going to actually just switch these. So the phone jack becomes the high output and the RCA jack becomes the low output. And I'm going to do it in a way that anyone can put it back without having to do any soldering. I'll show you how. So I've flipped the lid of the ARP Odyssey, and these are the jacks, the RCA jack and the phone jack. And there are these two shielded cables that come back here to board C. So what we're going to do is we're going to disconnect this, and with a nice sharp tweezers or something, we're going to release the Molex contact from the housing for connector 1 and 2, and we're just going to swap them and put them back in. Here I've released the two contacts, and I'm just going to swap them. So green will go where red was, and red will go where green was. And that's so simple, anyone can do it. And if whoever buys this keyboard, wants it to be totally original with the RCA jack as the high output, then by all means, they can just switch it back. Now comes my favorite part, where I get to spend a few hours with it and just mess around and make different sounds. Now I've got all the slider caps and the pitch bend knob back on, and I've put all the screws in, and it's ready to go. So hopefully this video was helpful in giving you an idea of what's involved in restoring and repairing an ARP Odyssey. And if you have any questions, please post in the comments. The kits that I use to repair this, the chip kit and the capacitor kit and the slider kit, are available on my website, synthchaser.com. And be sure to subscribe so you don't miss out on any of my future videos. This is Synthchaser from synthchaser.com. Thanks for watching and have a great day.